Thank you, Maya. Thank you, Tim, for inviting me. Thank you, Bettina, for this wonderful welcome. And I look forward to the panel conversation with you, Heinz. My lecture is a bit too long. And can you hear me? Okay, a bit too long. So I will try to speed up as much as I can. So, but the gist of the argument, my semi-provocation for today, or for the last few weeks, I'd say, has been that architects today are not building buildings. Architects today are building environments, whether they do it as microclimates, energy design, or in their contribution to carbon footprint and climate change. They are building environments. And this is an expanded definition of the environment, which I will try to get to. And which means to me, as an architectural theorist, is today we should be thinking about and articulating, developing theories of the environment in architecture. And I'll start with one example, for instance. How can we do this? This is a document that I'm sure you all know, UN Sustainable Development Goals, taken a lot more seriously here than in the United States, which is my main context, actually. We use this document when we apply for grants, when we propose big projects, especially at urban scale. But my second provocation is that we should actually be reading this as architectural theory, which means we should be, reading it critically. We should be understanding it. Some of them are quite clear. Ensure access to affordable, reliable, sustainable, and modern energy for all. And you could say, okay, we are doing this with our energy designs and architecture, or take urgent action to combat climate change and its impact. And we could be saying, yes, we are already doing that, or we're trying to do that in one way or the other. But it is more complex, the whole document, actually. Some aspects are very related to conventional definitions of architecture and urbanism. For instance, make cities and human settlements inclusive, safe, resilient, and sustainable. The others, what architecture can do, is not so clear, and I think we should exactly be thinking about what that means. For instance, this one, promote peaceful and inclusive societies for sustainable development. Building accountable and inclusive institutions at all levels. And I'm because a lot of architectures, yes, is based exactly at building and utopias that are related to that. That's what I mean. Be reading this text more as architecture, not as an instrument or a document that we write. And in relation to that, we should also be thinking about the definitions of the word environment. This is a document that takes both building and with building architecture and environment very seriously. And as architects, we should be doing it. So this is a philologist from early 20th century, Austrian philologist named Leo Spitzer. This is his work, one of his essays, Milieu and Ambience, and he traces these words all the way back to ancient Greek, to Roman, to Latin, to different languages. And as you see, kind of the word throughout his essay moves from basic common language to philosophy, to science, and to social sciences, finally in the 19th century, encompassing more and suggesting other kind of branchings, like the word field, or like the word ecology, and even race theory. Back to the surroundings, notion of the environment as surroundings. In this definition, scientific expeditions and their role play a very important role. And here are here's an example that I will be looking at, Voyages of Geograph and Naturalist to Australia, which was an expedition by Baudin, funded by Napoleon, along with several other expeditions. In Australia were here recognized as Nouvelle-Hollande, and they developed two ships. But I'm particularly interested in the drawings and engravings prepared on board during this expedition. So the fish, mollusks, zoophytes, all sorts of species that they were encountering, and you can imagine that them taking the fish out of the water, drawing, painting character represent the colors, or kangaroo, or land animals. But one thing that's especially about this drawing that's striking to me. So the kangaroo is depicted very clearly, very well, and it's eating something related to this tree, but we have no understanding of what this tree is. So what the sustenance of the kangaroo, and what makes it live, is not there. There are very little suggestions about the surroundings, about where it lives, and how where it lives might be impacting, affecting this kangaroo. And this understanding of the organism has a very clear impact on what happens afterwards. So they collect several species on their boats. They are going to take it back to this Natural History Museum in Paris, which is a newly established institution, relatively recently established institution, especially shaped by Comte de Buffon and Georges Cuvier. And actually, the museum's collection does not come from France, it comes from all over the places where these expeditions are taking place. But what happens when they take all these species, organisms, on their boat, only about 20% survive on the way back. And those that survive, because of this experience, they devise, actually, the gardener of the museum, Flynn, devises these containers called contresols, shaded containers, which allow the potted plant to receive the amount of wind, rain, and sunlight it needs to thrive. Such devices embody each plant's environment as a set of external factors that could be reproduced on garden's grounds rather than as climatic zones or geographical locations. So the surrounding is this kind of, what surrounds is this container, which is imagined to be able to recreate the external factors that the plant needs. This also is to a degree, but not fully, to the degree that Isidore Jefferson-Hilaire imagines a garden of acclimatization in Paris, which is this fantastical place where all different sorts of animals are able to live together, can live together. But at the same time, the Natural History Museum is a very serious scientific research organization. So several naturalists, natural scientists, which is new science at the time, are studying here, and especially under Buffon, and there are lots of drawings that are being produced. One of these figures is Augustin de Candolle, who offers a very interesting distinction between habitations of plant species and their stations. For him, the habitation is a general distribution of plants across the Earth's surface, whereas stations are the climate, soil, and other conditions under which a plant can grow. So habitation is general and can be anywhere, and station specifies the conditions under which it can grow. And he also emphasizes field work, so instead of working with exotic species, he says we can work with what we have, and this is the map of France, for instance, botanical map of France that shows the different stations in France for plants. Something interesting happens at the Natural History Museum in Vienna. This time, another painter, undertakes the study of underwater with a diving bow. So instead of taking the fish out of the water, he decides to go into the water and does these paintings, which one could say are more kitschy in comparison to the earlier ones that we looked at, but they actually start to reflect something else. So he's studying here, and you can see almost the shape of his window already in the frame of the painting. And when we compare these color lithography with the drawings made in the earlier expedition, I asked, what has changed? What is the difference between these? And another painting by Anthony. Another interesting object in the Natural History Museum in Vienna are these glass models developed by Blaschkas, the son and father, glass-blowing team. Around the 1880s, they are commissioned from scientists from all over the world to develop these glass models. And these are especially plants and sea creatures. In here, you can even see exactly what was drawn here in the Napoleonic expedition of Australia and the Blaschka's representation of the same creature. And the question is, what does the three-dimensionality of the model bring now to the representation? And it brings several things. It brings materiality, transparency, translucency, but there's something even more. For instance, they developed this after watching the sea animals in their aquarium and seeing them in a territorial fight. And they attempt to describe it with these wires. So the species, specimen, or organism starts to display behavior with these models. And very soon after, or around the same time, neural theory will be established by Santiago Ramon y Cajal, and even Sigmund Freud, in the very beginning, is working on this. So what to say from Baudin's expedition to Blaschka's models, and in between Nasser Village, underwater diving well, what has changed is the definition of the organism, the definition of the environment, and their interrelationship. Like all of a sudden, organisms are interacting with each other, they display behaviors, and they have some relationship to their surrounding. That's not necessarily described yet, but surrounding is definitely something that's been input to the organism. And I will be doing this like flash forwards, like I'll be going through these 4 distinct histories and giving some suggestions about contemporary versions of these. We could look at this work by the artist Michael Wang, Extinct in New York, where he researched these extinct species in New York. I mean, they're not extinct in nature, they're only extinct in New York. And he produced drawings of them, he located their sites, and then he built his own versions of the contrasol, basically trying to make these species grow, and then these species were redistributed back into parks and public spaces in New York. So he hasn't traced what happened afterwards, so we don't know if these species are back in New York or not. But this is the work. And here are the glass houses that he designed and built for this work. Now I want to go into the definition of the environment as ecology. I pointed to one aspect of the changing definition of the organism and its surroundings, but the definition of the organism itself is changing, and this relates to how organisms are related to each other. How do different species relate to each other? And there is, in the middle of all, revolutions in the 1830s, Cuvier and Geoffroy Saint-Hilaire launched a major battle, scientific battle, on how to classify animals. So for Cuvier, there are four forms, there's four distinct plants, organizations: vertebrates, mollusks, articulates, and radiates. They are all distinct, and for him, function determines the structure, as in what the organ does is the structure. For Geoffroy Saint-Hilaire, he comes up with a much more theoretical, hypothetical statement. He argues that the shape of organs are transforming in response to external stress. Forms, organs change all the time, but in basic form, he says all organisms share the same unity of composition. They're all the same, is what he's suggesting. It's these environmental factors that are changing things. And what stirs the debate is this drawing, actually. Geoffroy, so this is a hypothesis that the section, when you fold a fish on itself, resembles the section of a mollusk. Geoffroy claimed that this proves his thesis. Internal parts of vertebrates and mollusks follow the same principles of connection, and for 2 years the French public is watching these two scientists debate each other. And Cuvier has a whole natural history museum behind him with lots of drawings being produced, taxonomy being expanded and classified more and more. And Geoffroy is basically trying to argue for a theory that he can't really prove. And this relates a little bit to the earlier debates on taxonomy. For instance, Linné's taxonomy, he specifies, classifies plants and animals. And there's also Goethe's contribution to this, which is his notion of the Urpflanze, which is this ur plant that has all the components of plants. And Goethe also agrees in this debate with Geoffroy, but he introduces, he says maybe we should be thinking about another term, namely type. And the conversation that they are having is not so distinct from what's taking place also in architecture. This is Henri Labrousse and Quentin de Princi, who are debating on the origins of architecture, origins of particularly classical architecture, and Labrousse pushes forward the statement that buildings change. There is no such thing as a singular one origin, or that origin is always going to be eluding us, versus Quatermain is saying there are universal principles. So for Quatermain, there are three types in architecture: a tent, a cave, and a hut, basically. And all forms of architecture can be traced back to that. So Egyptian architecture, and what stirs the debate there is another expedition by Napoleon, this time to Egypt. And so all of a sudden Egyptian architecture comes to the fore with all these drawings. So what do we do with this? We know it's before Greek architecture. Does that mean that's the origin of architecture? How can we argue for their differences? And how can we still maintain the classicism of Greek architecture? So that's what stirs initiates this debate. And what Quatermain basically resolves this by saying there are three types. Egyptian architecture, you trace it back, goes to the cave. Greek architecture goes to the hut. Labrousse, on the other hand, is like, that what you think is Greek architecture is actually not. This could be it. It's colorful and not glowing, looking like a hut. So that's the debate there. At the same time, fossils are discovered with a lot of infrastructure work taking place. So this is the ground of Paris, for instance, drawn by Cuvier. And in this moment, Cuvier also single-handedly identifies extinction as part of natural history. There are species that no longer exist. And he says, with my theory of functionalism, once I know I'm gone, I can reconstruct the entire animal. Once you know one part, you will be able to know the entire whole. And so, for instance, one of the things that comes to Cunya's hands is this crocodile found in Cannes, which reveals that Cannes was a marshland before it having the current limestone bedrock. And the discovery of fossils, therefore, are changing not only like rain for species that no longer exist, identifying extinction, but also show that the ground itself is changing, it has a history, it has a background. So very complicated. So like surrounding itself in a way is changing with organisms that no longer exist. And the ground that gave that the organism was living on also like is cellular part of the ground. And what happens is basically Cuvier, with all the power he has, initially succeeds in convincing the public and scientists of his theory, but Jeffrey's theory becomes also significant, especially as it is recognized by social reformers for breaking boundaries between distinctions and classes. So it becomes some kind of the social theory that these classes all come from the same human kind. And scientifically speaking, Lamarck also bases his theory of inherited transformation, which is the early version of evolutionary theory, on Jeffrey's theory. And interestingly, going back to the question of environment and surroundings, I think it's super interesting that mollusks or shellfish become a metaphor for humans and human history. So what's the relation between a society and its built forms? What shapes what? The shell or what lives inside the shell? So these two become kind of intermingled. And organisms in this debate also emerge as a complex structure with parts whose relation to the whole have to be always constructed, thought through. So it's a little bit in this context, but in a different one, in the German context, that Ernst Haeckel coins the word ecology, which he defines as the entire science of the relations of the organism to the surrounding exterior world, to which relations we can count in the broader sense all the conditions of existence. And he says these are partly organic, partly inorganic, partly biotic, partly abiotic. The word is derived from the Greek word oikos, meaning household or home or place of dwelling, and also consider, like keep in mind the relation to economy or economy, ecology and economy. Ecology being the logic of home, the science of home, and economy being the graphics or measurements or the economy of home. Yes. But how did he come about? So he is looking into radiolaria, which are these very, very tiny protozoa that produce these mineral skeletons, and they are found as zooplankton throughout the ocean. And their remains actually on the makeup of the cover of the ocean floor and draws on nearly. So what is this kind of minute, tiny creature doing in its surroundings? What is its role? And what is its form? What is its structure? And through these studies and through the definition of ecology, basically he develops phylogeny, or the relationship of species to each other. And significantly, in his phylogeny, they all come together. Plants, fungi, animals, they're all related to each other. So, and this becomes highly debated, and he does become somewhat of a cast out. At the same time, or around the same time, this scientist, Möbius, he basically looks at organisms and their organisms, especially the oysters, and their relation to their surrounding. And he defines the term biosynthesis, which leads to an understanding of community ecology, like how
it's not only about one species or one organism in relation to another, but actually a lot, like several of them, like how they form, let's say, communities. So here is the book, oysters and oyster colony, and we live together. Now, flash forward, actually, this becomes a very not recent, like 10-year-old project by Kate Orff. She developed a project called Oyster Texture for the Gowanus Canal in New York. So Gowanus Canal is one of the most polluted sites in New York, if not in the entire United States. It is called a Superfund site, so the money Superfund meaning there's a lot of funding to be able to clean it. And Kate Orff's proposal was actually to clean it with the oyster, which can actually filter the water, and develop entire oyster shells, oyster beds in the zone. And this goes back to the history of New York. So she studies the history of the city and history of the landscape. And in 18th century, basically there's a very kind of vibrant shellfish culture in the water, to the degree that, I mean, it is so, Gowanus oyster is so famous, there are books about it, and like this is the whole kind of oysters collected and so on. And this is a history of New York from the perspective of this oyster. So it's actually an important inhabitant of the city in the 15th century, and it can't survive because of being overfished. And it is basically really a community ecology. Like once the number decreases beyond a certain level, it simply won't be able to survive. If the community becomes too small, it will disappear altogether. So for that, Kate Orff proposes this, basically large communities of oysters coming back to New York, to Brooklyn, and starting to occupy the space, to the degree that in summer 2025, we could imagine a state park where the super polluted site is, and by 2050, there could even be a reef, Palisades Reef State Park. So this project was developed in relation to the MoMA competition, Rising Currents. So part of its goal is not only to kind of clean the water, but it's also like the big ambition is this: these reefs can actually try to mitigate the rising sea levels, rising water levels that will be threatening, especially this part of Brooklyn. Now, another definition of the environment as energy, this time as resources, energy and resources. So this occurs at the time of, so we're again back in the 19th century, a little further in the middle of it, invention of the steam engine. And just brought these two images, so here you see the steam engine, and this is actually oil drilling from China a little later, to show you that the history of energy is very non-linear. But something happens in the 19th century that energy becomes defined in relation to resources, in relation to work, in relation to bodies. So humans have been dealing with energy in different cultures, in different societies, in different contexts throughout history. However, in the 19th century, there is a convergence. And a singular notion of energy takes precedence, which is related to, as I said, work, production, and increasing energy, to the degree that actually Ilya Prigozhin in Order Out of Chaos, Isabel Stengers and Ilya Prigozhin defined it very nicely. Like prior to the 19th century, the idea of science or mechanism is a mechanical clock. By the time we get to the 19th century, after what's called the Industrial Revolution, it is an energy as a resource that can always disappear and stop working, like dissipate. Like it's not going to disappear, it's going to remain, but it may not be able to put to work. So humans start living with this fear. Or like constitute this chemistry of combustion and illumination, like all like this, and I'm trying to understand the structure of fire, the structure of a flame. It's even called the structure of flame. Or this map by Charles-Joseph Minard in 1866, showing coal export out of England, the resource coal, and it looks like almost like an octopus going all over the world. So basically, like with energy, environment becomes very much related to or understood in terms of resources as something that can be calculated and eventually managed as well. But let's look at some more drawings of this time. For instance, these are Alexander von Humboldt's drawing a very famous section of the Earth. But also there are these less famous ones that we don't necessarily look at as architects, which are electromagnetic currents of the world, or air currents and water, like air currents in water and in the air, and their relation to each other. Or again, like the year, basically, the temperature changes throughout the year and how it can be mapped. And finally, like plants and their organization all across the world, not only in plan in the world, but also in section, in elevation, that you see. So with Humboldt, like with this notion of environment as resource, environment as energy, Humboldt actually tries to, like, or I am arguing that Humboldt is trying to kind of show us give us an entire picture of the world, of the earth, of how these different forces or currents are related to each other, and how they give, sites or habitation for different species throughout this cosmology. And at the same time, it's someone like Dr. for instance, who's considered the father of the study of soils in their natural context, like looks up, so if there's this big picture, what is actually taking place in the soil, in Earth? And he finds tons of places and locates it throughout. So I kind of goes from this big picture, global picture, world picture, to very specific soil, and what it can do, what kind of a resource it is for everything that moves on it. This question becomes much more specific during and after the World War I, when the field of geochemistry is established as a result of the search for mineral resources. And there's something very specific here. There's a tungsten shortage, tungsten form of metal, there's a shortage in that. And this sends several scientists, especially chemists, in search of here, basically. And he, with this, also develops new methods for measuring biochemical processes at very different scales. And that kind of opens this up to the cosmic video in a way. Like, as I say to my students, he is the first one who said we're all heart, we're all stars. Like, we're all stardust, basically, heart of stars. So he says it in his own way. And Goldschmidt what he wanted to do with his geochemistry is basically he wanted to reconstruct what he calls the metabolism of the earth, namely the chemical geological transformations, including the cycling of nitrogen and other elements between land, atmosphere, and oceans. he used, as I said, like they were also not only kind of grouping theories about how things are related, they were also inventing their machines for measuring things. So this is one of his machines. But what he wanted, his ambition was to create a history of the planet through atoms, like hydrogen atom. Like what would the history be according to that? And this would include living in non-human. So the field expands, especially with Evelyn Hutchinson in the United States in the early, a little bit later in the 20th century. He starts looking at lakes, and this cycle he describes. So what's the relationship between the fish and its food, and its food's food, but importantly, what's its relation to the sun? What's its relation to what's outside the lake? How does that contribute to this cycle? And of course, this is the source of energy for this system, which is further developed by these two characters, Eugene and Howard Odom, who define, finally, from 50s onwards, the role of energy in ecosystems by means of these types of energy flow diagrams that they draw. These are almost like circuits, or like this is a really like a drawing that several landscape architects love. It is called, and it's Howard Odom's description, drawing of a river. This actually is a river, but he's defining the river, he's drawing it only in terms of energy. So it's showing the flow of energy in the ecosystem of the river. So input, output, imports, exports that he talks about, photosynthesis, its role, respiration, its role, temperature that's excess and cannot be used, that leaves the system. And he basically draws the river as a flow diagram, almost like a machine, thermodynamic machine. Now, flash forward, two examples of this, and I am particularly looking into landscape here, or large scale projects. So this is Neves Studios' Museum of Lost Volumes, where they are proposing to build a United Nations funded studio of a museum of extraction. But in terms of extraction, instead of looking at what's being extracted, like minerals, they want to collect and document the sites of extraction and how that can be, how that can be kind of a museum for humanity. Or another example is Design Earth's Geostories, where they draw basically, for instance, what happens in this coal after oil. What happens after oil between these two states, Iran and United Arab Emirates, and all of a sudden there's kind of a city that's beginning to emerge between them in that Gulf. What I find, especially, or another version of after oil, what happens to the oil shaft after oil, or another one of oil and ice, which is based on a story they heard about transporting a whole part of a glacier in water to the Gulf. And this is their kind of interpretation of that story, or possibility of that kind of oil is in exchange for ice is to produce water for that region. What I find fascinating in both Nimley Studio and Design Earth drawings, though, like where I think it becomes super specific architectural and in a way theoretical as well, is how they not necessarily or not only the story that they tell, but how they tell it. The drawings always reflect back on history of architectural drawing, particularly of like 70s. So this is, for instance, can be related to superstitious continuous monument of one sort. This can be related to earlier drawings of, for instance, Magnitogorsk, another kind of mega energy project, one could say extraction project in the 30s, or in the case of Neme Studio, Delirious New York, City of Captive Globe, now turned into this kind of extraction site, or site of extraction. So and I always tell this to my students, it's not only about, like, in a way, the content of the story may be about extraction, may be about energy, but a major part of its theory will also be its reference and how it becomes, or how it becomes architectural. That's very much part of the reference, and redrawing, reinterpreting the reference. Now, do I have time? I want to go to the last one, action and policy. Environment as action and policy. We're looking at the environmentalist movements and where they come from or what they relate to. So, a very important hypothesis was made in the 70s, the Gaia hypothesis, which proposes that all organisms and their inorganic surroundings on Earth are closely integrated to form a single self-regulating complex system, maintaining the conditions for life on the planet. So this was the work of James Lovelock, the chemist and microbiologist linked my goodness. And it focuses on observing how the biosphere and the evolution of life forms contribute to the stability of global temperature, ocean salinity, oxygen in the atmosphere, and other factors of habitability in a preferred homeostasis. In other words, this is like poo-poo, but much more developed. It shows how everything is related to each other on Earth. And for instance, NASA, these two, this is the famous Blue Marble, but Blue Marble 2.0. For over 2 years, NASA developed this project to photograph the Earth from the east and the west. And they did this in order to study, just by the color of the ocean, for instance, to study the ocean acidity, salinity, the currents in the air. The over 2 years, like, they basically juxtaposed several images and heated this, and this became a very important document in understanding what's taking place in the oceans, for instance. Now, and it is basically an interpretation. It is based on the Gaia hypothesis that we can understand the Earth as a system. It is the hypothesis, though, was initially received with hostility by the scientific community, and now it is, studied as part of Earth system science, adopted in different fields like biology and chemistry, systems ecology, and most, I think, for our purposes, maybe as architectural theorists, it is also taken by important thinkers, cultural historians, and philosophers. For instance, Bruno Latour's Facing Gaia is very much based on this, or Alexander Etkin's Nature's Evil, the cultural history of natural resources, also considered Gaia as an important as part of the overall picture that he's presenting. But what the Gaia hypothesis presents is that Earth is not this all nice kind of welcoming Mother Nature who's going to kind of accept whatever we do. Gaia hypothesis actually accepts that Earth is much bigger than us, and there are depictions of this type of Earth in history of humankind. For instance, this Vasari's mutilation of Uranus by Kronos. Gaia is this figure, the god of Earth, who is basically helping her son mutilate Uranus because he did something wrong. So this Gaia, the Gaia of do, it is a system of its own, and it is going to get rid of whatever is not working. So, and this is something that both Etkin and Bruno Latour are picking up on. Right? It's not this earth, it's not ours to be kind of paternalistically protecting, but it's actually something that can spit us out. So how do we live? How do we make some kind of peace? But also, like for me, the most important question, what's the role of design in facing this other kind of earth? Is it some kind of fixing, some kind of solution finding, or is it some kind of community making? And these are open-ended questions that we can discuss. Going back a little bit, specifically to the beginnings of environmentalist movements, a very important figure is Rachel Carson in her Silent Spring, which is written in response to basically chemicals that are used to kill insects that are, killing the crops, basically. So that's the main kind of argument, or that's the main problem that she's addressing in this book, which becomes a very popular book, immediate bestseller, and it causes a big problem actually. I mean, like, not a problem, but the pharmaceutical industry, the chemical industry, immediately kind of wants to take the book apart and prove her wrong, to the degree that she has to testify to the Congress in 1963. And she says this, which I think is one of the best statements. She's, I think, one of the most misunderstood figures of the 20th century. But this, I think, is one of the best statements about environmentalism that's ever been made. And I'll just read it because I like it so much. So, she says, when we review the history of mankind in relation to the earth, we cannot help feeling somewhat discouraged, for that history is for the most part that of the blind or short-sighted despoiling of the soil, forests, waters, and all the rest of the earth's resources. We have acquired technical skills on a scale undreamed of in the generation ago. We can do dramatic things, and we can do them quickly. By the time damaging side effects are apparent, it's often too late or impossible to reverse our actions. These are unpleasant facts, but they have given rise to the disturbing situations that this committee has now undertaken to examine. So, Carson here is not a Luddite. She's not saying, her argument is far more nuanced than it's been understood by her enemies, actually. She's not saying technology is bad. She's not saying the chemicals are bad. Only problem, she says, we do them quickly. So she is a marine biologist. She is an evolutionary theorist. What her problem with technology, using a technology like chemicals and getting rid of insects, is that there is no time to adapt. So there's no time to adapt for insects, there's no time to adapt for the birds that eat those insects, but there's also no time for us humans to adapt to that. That's the main problem that she sees. It's not technology, it's its speed that she sees as a problem, which I think that Gregory Bateson, in his Ecology of the Mind, interprets quite well in the relationship he sets up between technology, population, and hubris, and how they lead to all these different things like pollution, famine, and war. So what happens after she does this? Actually, quite good things happen, but she doesn't live to see them. The National Environmental Policy Act is created. It's signed into law in 1970. Which basically means that there needs to be a statement of environmental impacts for all major federal actions significantly affecting the environment. So imagine you want to build an island, you need to prepare an environmental impact statement. And then that document becomes a main document that's continually used. In 1970, after the Policy Act, the Environmental Policy Agency is founded, which becomes its own institution. And finally, in 1970, there's also the first Earth Day. And this is just fun. So, Rachel Carson becomes a very popular figure also, as you can see. And Earth Day imagery that we have, as I said, she doesn't live to see, which I think owes also a lot to how Strucker coins imagery coming around right before the Earth Day, including the OASE project. But one problem is both the Earth Day and this kind of general environmentalism that is read from Carson and others is that it doesn't necessarily recognize or acknowledge that there are multiple environments. There are different impacts. And there are different communities or groups that suffer those impacts differently. So, and this becomes very clear in this moment that Louis Gibbs establishes in the Love Canal in Niagara Falls in New York. It's basically a major environmental disaster in the history of the United States. Love Canal is originally in the 19th century, beginning of the 20th century, built as this kind of beautiful place with canals, almost like reminiscent of Venice. It's like this beautiful, a little bit outside of the city area. Then chemical industry moves in, a major chemical factory, which starts dumping its waste into this area. Now, what happens in the 60s is that that area that you saw in the earlier slide becomes rezoned, which means in American terms, different activities can take place on it. The land can be sold and used for different things, so it's no longer just a waste site. It becomes rezoned as a school district, which again, in American terms means there can be houses. This can become a neighborhood. So there are houses here, as you're seeing. It's developing as a suburb, where previously, or right, very close to it, there are these kind of situations. And what happens in 1 year, there's extreme rain, and these people's houses are flooded with brown matter, like not even water, like brown stuff, liquid. And that's when the people who are living there learn where they are living. And then Louis Gibbs basically launches this very big campaign, like, how can we be living here? And she gets children involved. This becomes incredibly effective and in fighting, and basically they do move out, and they are relocated and all of those things. It also becomes a very important part of the environmental history of the United States. But what this brings about is, okay, environmentalism is one thing, caring for the environment is one thing, but different sites have different problems, and some sites have much more urgent problems. And something that's, I think, picked up recently as well by indigenous environmentalist movements. For instance, here is the Standing Rock. I don't know if anyone remembers, from 2016. It's again a very American phenomenon. This is when the water protectors kind of established themselves as a group dedicated to protecting the water. So just to give you a brief summary of that event. So there is this famous natural gas pipeline, the Dakota Access Pipeline, going all the way from Canada to the United States. So there is an environmental impact statement developed for this. pipeline and where it should go through. This is the alternative that's proposed, but this is rejected. And this is the one that's kind of faster and easier, that's established, that began to be built in 2016. But the problem is, this is the unceded Sioux territory. This is an indigenous nation of America. So it's their land. So this pipeline can't just pass through someone else's land. And as a result, there was a big protest for several months in 2016. And it was a very big political battle. It was Obama administration's last few months. Obama basically initiated an extended environmental impact statement to study. Just one more thing to note, I mean, water it's not only about going through their land, but it's also basically this is a sacred body of water for them, the Lake One. So the land has different meanings to different people. It's not just like something that passes through, that one passes through either with gas or with car, but it actually means something different to the people who are there. And as I said, Obama wanted an extended environmental impact statement. As soon as Trump came to office, that statement was kind of closed and finished, basically the pipeline had to go, and it was realized. But one thing that this did achieve, actually, was to highlight the notion that, as I said, land is a different thing for different groups. It's not only about, the efficiency of how one resource of energy can pass through a terrain or a territory. It means different things. Different groups attach different meanings to it. And as I said, like environmentalism is not one big general thing. It actually has very specific sites and locations. But one thing that came out of it is basically this water protectors as a movement. They became a global movement, basically in different places across the world, especially in North America. So this is Christy Bedford, an indigenous artist who developed this series, Water is Life, and I really kind of appreciate how she relates the river and the water to like how different species are related to each other in the body of the water or through the body of the water in her depictions. But what is a river? Is a question we can ask after seeing something like Standing Rock. Is it a landscape? Is it a resource of energy that we will see in hydroelectric dams? Is it an ecosystem? Is it a legal person, which I remember became a legal person in New Zealand in 2017? Is it a sacred site? What is it? Right, it's all of those things, of course. Flashed architecture, so, and here not a flashback, because this is, am I not?
Slowly we could.
Yeah. And flash architecture, I am not flashbacking now because this is present. And just one thing I have to say more, like I don't think environmental activism is necessarily an architectural act. I think the relation between environmental activism, climate activism, and architecture has to be very carefully constructed. So I don't have an example of that. But I think there are other types of interesting works, especially in the realm of research, not necessarily in the realm of built work. For instance, this by Julie Watson, Low Tech Design by Radical Indigenism, where she goes there and discovers these incredible infrastructures. Like these are infrastructures, like they are, like imagine this more as a highway than as a, beautiful bridge. But that's what it means in this context, basically. And what she does, I think, ingeniously, is the drawings of them. representation will come. So she shows how these infrastructures or these structures are architecture, not just some kind of local dimension. So, and by drawing it, I think she shows also what you can learn from it, like what the complexities of form are in this case, what the complexities of materiality, what the complexities of tectonics are in a structure like this. So I think in the realm of research, there's a lot to be done, and I think Pablo Tavares also does very interesting work in the realm of research, in forests and trees and how they become and their relation to architecture and urban settlement. So I presented the first 4 of these, and I asked you to think, what your definitions of environment are. There's another thing which is that I have been thinking of, and I haven't necessarily done, but are these architectural theories of environment. So how could we write a whole kind of theory of environment, architectural theory of environment, like what would its chapters be? And I fantasize about this sometimes for a year. So for instance, a geological theory of architecture, what would that be? Arboreal theory of architecture, what would that be? And I think Pablo Tavares is doing a great job at showing that. Bestial theory of architecture, what could that be? And I think Catherine Ingram is doing that, for instance. Microbial theory, what could that be? Climatic theory, thermodynamic theory, or waste theory, kind of dump theory of architecture. So I have all these kind of questions, and I kind of map out how I would do it as well. Like if I were doing the geological theory of architecture, I would be looking at ground and the history of the ground. Arboreal would be about site, bestial would be about subject, microbial would be about interiors, climatic about openings and thresholds, thermodynamic would be about organization. I don't know what waste would be. I think about it. But bigger question is, what's architectural theory? And one definition that I work with, and I think there are different definitions, I recommend everyone to have their own definition, goes back to this word, hieros, related to seeing, related to being a spectator, related to contemplating as being a spectator. It has to do with seeing and making things visible in a particular way, showing, making things visible. And this is my definition of theory. It is what establishes the relationship between what is present and what can be imagined, allowing us to look forward and backwards. And I think it's the task of architectural theory to consider what remains constant and what changes in the discipline as it addresses current challenges, including environmental and climate crises. If I have 2 minutes, I would like to show just one more thing. So this is like how would be the question. This is an exhibition I co-curated recently at the Angelante Interdisciplinary Lab. And what I did for this exhibition was this timeline. So the exhibition was about energy and making energy visible, or visualizations of energy, but not necessarily the engineering visualizations, but different visualizations. And mine was a timeline. And I think actually a timeline relates quite well to how I think I can do theory. Because as they have references and images that are kind of free floating, that are related to a history, a timeline document. So